A highly regarded methodology used in design, engineering, and business fields to promote innovation is known as design thinking. As shown here, design thinking consists of 7 interrelated phases. The first 3, understand, explore, and define, involve developing a deep understanding of the impact of the design. Included at the top of the list are the vast bodies of scientific concepts that govern the natural world. For example, creating accurate models of water has helped scientists and engineers further understand the properties of water, allowing for the design of more efficient steam and geothermal power plants. As demonstrated in the technical videos, you will see how 123D design software can help anyone, regardless of their prior artistic or technical background, engage in the process of ideation. These same tools will enable you to take this or other projects of your choice through the remaining stages of design thinking that include prototyping, refinement, and presentation of final solution. Knowing how important knowledge of science is to the design thinking process, we now present the following overview of concave and convex surfaces, their properties, and their applications. The terms concave and convex are used to describe the shapes of different surfaces. These shapes allow for the design and construction of many useful devices that are used in many different fields, ranging from science and infrastructure all the way to recreation and leisure. In this video, we define concave and convex shapes and look at a few common applications, followed by a design project in 123D design, which is detailed in a series of technical videos where concave and convex shapes are used to create a chocolate mold. There are multiple definitions for concave and convex, including mathematical and physical definitions. However, we'll be using the 2 general definitions for concave and convex. A surface that bends endward is generally defined as concave, whereas a surface that bends outward is defined as convex. In physics and engineering, concave and convex are often used to describe the shapes of lenses. Lenses distort the paths of light. How it is distorted, though, depends on whether the lens is concave or convex. A concave lens bends light outward. Sometimes it's referred to as a diverging lens. This means that an object viewed through a concave lens appears smaller and farther away, while at the same time, the viewer can see a wider field of view, as if they were farther away. We use them in eye holes, so that way when the viewer is looking through the small hole, they can see the entire person standing on the other side of the door. Convex lenses bend light inwards. This is why they are also sometimes referred to as converging lenses. This provides 3 useful functions. First, an image can be magnified. Second, light can be focused on a specific point. And lastly, an image can be flipped upside down and left to right. Here are a few examples of convex lenses being used. Telescopes magnify images using convex lenses, while emergency magnifying lenses focus light in order to start fires. Overhead projectors flip and magnify the images. The degree to which light is distorted through either a concave or convex lens is dependent on the curvature of the lens and the material the lens itself is made from. Concave and convex mirrors are similar to lenses in that they distort the path of light. Concave mirrors are similar to convex lenses in that they can magnify an image, focus light, and flip images. Here we can see concave mirrors being used to focus light for concentrated solar power production. Convex mirrors function similarly to concave lenses in that they reflect light outwards. This causes images to appear farther away and increases the viewer's field of view. Convex mirrors are commonly used to increase people's fields of view, such as at a blind intersection or cramped grocery store aisle. Concave and convex shapes are used in more than just optical applications. They're also used in physical applications. Common applications of a physical concave surface often involve catching or holding a gas or liquid, like a bowl. Here we can also see a concave parachute, catching air to slow the descent of an object. In contrast, a convex shape is often used to reduce friction or drag, such as the saucer sled or in molded parts. Molds play a large role in manufacture and design. Most molded shapes have convex surfaces and are tapered in order to aid in their removal from the mold. In the following videos, we will be designing chocolate candies and, consequently, the molds that they must make them in, using convex and concave shapes.